Now we're going to be looking at page 2 of the Chapter 4 AP packet, and we're going to be going over how to write complete molecular equations, complete ionic equations, and net ionic equations. And these can be done for precipitation reactions, acid-base reactions, and oxidation reduction reactions. Here's the example given. Sodium sulfate reacts with barium chloride to make sodium chloride and barium sulfate. This is going to be a precipitation reaction because this is soluble. Sulfates are soluble, except for capacitor pub hog 2. Chlorides are soluble, except for trickle, except for the happy tickle, HAP. This is going to dissolve with group 1 and chlorides, and this will not dissolve because of the capacitor pub hog 2. So now what we're going to do is we're going to balance it. So there's a 2 in front of the sodium chloride. And then what we're going to do is break it up into ions. So any aqueous thing is going to break up into ions, and you just have to count how many there are. So if this is Na2SO4, there are 2 sodium ions right here and 1 sulfate ion right here. Barium chloride is going to have 1 barium right there and 2 chlorides right there. 2 sodium chlorides means you have 2 sodiums total and 2 chlorides total, and then 1 barium sulfate is going to stay by itself. Now what you're going to do is you're going to look for the ions that are repeated on both sides of the equation exactly the same way. So sodium ion here and sodium ion here are exactly the same, and you will see that the chloride ions here and chloride ions here are exactly the same. So you will not include them in the net ionic equation. The net is just going to be sulfate plus barium yields barium sulfate, and this is called the net ionic equation, which you got from the complete ionic equation. You could do the same exact thing with acids and bases. Instead of making an insoluble salt, you're going to make water. And water, again, does not dissociate. It's a molecular substance. It doesn't break up into ions appreciably. So you balance this equation by putting a 2 in front of the water. And actually, you will also need a 2 in front of the HCl, so you need to add that into your notes right there. And now what we're going to do is break this up into all its ions. So you're going to have 2 H pluses, aqueous, for the complete ionic equation. And you're going to have 2 chloride ions. And then you're going to have 1 barium ion. And then you're going to have 2 hydroxide ions. On the right side, you're going to break up the barium chloride because that, again, will dissolve into ions, dissociate. And you get 2 water liquids. Again, we're going to look for the ions that are the same on both sides. They're called spectator ions. So I should have written that over here. Spectator ions. And we're going to look for the same ones on both sides. So you can see the chlorides are repeated right here, and the barium is repeated right here. So your net ionic equation is simply going to be, right now, 2H plus aqueous plus 2OH minus aqueous yield 2 waters, liquid. And you should notice that even this is not the simplest because you can get rid of all these 2's and just have H plus OH minus yields H2O. And this is the net ionic equation for the reaction of HCl and BaOH2. And in fact, this will always be the net ionic equation for a strong acid and strong base reaction.